do something, else if current state equals states. Oh, no. States. Fetch. Do something, else if current state equals states. Oh. Return, do something else. Does that make sense? I figured out how my agent should behave. I know that there's 3 states, so I created those 3 enums, and now I've got ifs to say, when I'm in this state, what should I do? And so then the way I like to program it is to say, if I'm in the wait state, and if my transition happened, somebody wants me to go fetch, just for simple purposes here, input get key down F. Somebody hits the F button, you should go fetch. You want to do something more complicated in your version, but that same idea should happen here. So, what should happen when we go fetch? How should the state of this dog change?
Its target should become the hole or whatever you're fetching.
Yes, the destination of the agent should become the position of the target. Here's where that line can come in. Agent destination equals target transform.position. Okay, that's enough for us right now. And I also want to say current state equals states fetch. I move from the wait to the fetch state, taking some action to make it happen and some condition of when I wanted to move. So, what state am I in? Should I be moving to a new state? So, that's good for us. Let's go see if that can happen. Now let's go make it happy. Let's go turn off our audio listener. Much better. Let's go play compiler errors. Oh.
Just turn off your audio listener. You turned it off, but then you were.
Oh, I was playing. Oh, I hate that button. Okay. So then what are my errors? I see nothing.
Click on the.
Oh, okay. Equal cannot be applied to.
It's because we didn't cast the states.
Oh, I didn't cast all of them. Yes, perfect. Thank you. Yes. So anytime you talk to those states, you have to cast it to the right type.
When you. For it to move, do you need to tell it that you need to set if its current state is fetched that it should move there, or will that?
So this says I'm currently waiting. Somebody hit the F button. I start running, and I change myself to the fetch state.
Oh, okay.
So I am fetching here.
Okay.
And only in here am I going to say, hey, should I change? I'm going to set up some other if statement to say, hey, should I change from fetch to going back home? Okay, hey, they're gone. Input key named F is unknown. Maybe it's a lowercase f.
I think you do like keys dot.
Okay, cool. I hit the F button. It runs up and does it. It was in the wait state. It transitioned itself into the fetch state and went to go get it. Cool. So that's where we are. Any questions? Let's finish this out then. I wanted to return. When it fetched it, let's bring it back. Okay, so if you're fetching, I need some kind of condition to say, swap myself out of the fetch state, put myself into the return state. How do I know when I'm done fetching?
Check the distance between you and
Let's look at that distance. Yes. So, if the absolute value of the distance between transform.position minus target transform position, I need another parenthesis, dot
vector 3 has a
magnitude. Oh, it does?
Yeah, you can do vector 3 dot distance and give it to vector 3 and it'll calculate the distance between.
Okay. That probably does what this does.
Yeah.
Yes. So, good. I'm glad there's a simpler way, because that's kind of long. But figure out your vector between the two spots. What's your magnitude? Absolute value of that tells you your distance. If that distance is less than 2, then you're there. Let's change my agent destination equals human transform position. Current state equals int states return. Okay, you ready? Go fetch. Gets there. Comes back to me. And it sort of runs into me. Bumps me out of the way. It's like, hey, I got the ball. I got the ball. What do you want? So, notice F doesn't work anymore because it's still trying to return to me. It's in the return state, and that F is only read inside the state when it's waiting. So, back to it one more time. We know that we have gotten there. If we're not talking about target position, but human position, let's set our destination to null. We're going nowhere, and put ourselves into the wait state. Parsing error, line 47. I forgot to close parenthesis. Yes, thank you. Ah. Can't set it to null?
Can you just set it to be its position? So that won't be
That would probably work. I'm pretty sure I set it to null before, but maybe I got an error. There we go. Okay. Fetch. Come back to me. There we go. Let's run over here. Fetch. Come back to me. We've got some states going on. Okay, so this is a really simple state machine. Questions?
no.
No? You're good?
Yeah.
Yeah. No? No?
Sorry.
You're good? Okay.
Yeah.
I understand. Sometimes things are funny. Especially with dogs. So, this is a really simple way to get some states and some AI behavior into your program. I sketched it out. Wait, fetch, and return. We put it into if statements. It gets kind of hard though. It's easy to implement. I did it really quickly here. You can get stuff done. But now we say, wait a second, I really wanted it to wander when it comes back. I want to set up some kind of return, goes to some kind of wander state. And then that wander state should go back to the returning state. and then return should go to wander sometimes, and this should have a probability in there. You can piece those together, but your code starts to get more complicated. Else if, etc. If you're in the return state, you might want to flip a coin, and every 10th of the time go to the wander state and then come back. You can put those together, but it's much more of a burden on the programmer to get this kind of stuff done. It's much more of a burden on your thinking beforehand about every single possible state and every single possible connection between them. Because if you're running through your game and you're working in partnership with other people and the designer is sitting there trying to make the game and he's like, I want this behavior to happen differently. They have to come talk to you because they probably don't know as much code as the developer does who made the AI for it, and you have to go reconfigure it and figure out a whole new state machine and lots of new transitions. You basically throw your code out and start over again. They're nice, quick, they get the job done, but they're really hard to maintain and are rather inflexible. So that's why Thursday we want to learn about behavior trees. It starts to separate the idea out of the behaviors of what's going on from the transition graph and lets the transitions sort of be created in a tree-like structure. They're much more complicated. We'll look at them. We might not implement them ourselves, but we'll see just ideas behind them, see how they might work, and see where you can find other tools about them. But any questions? This should get you going to make your dog. This should get you going to make a lot of things happen in your games because you're familiar enough with code to think about if statements and make that kind of thing happen. Any questions about state machines? Okay, any questions from the chat? We're looking good. So let's spend the rest of our time today working on your implementations. Should have some good basis and foundation. I ran through some stuff quickly. You should have that. Oh, and the last thing, I wanted to say, I want to change levels. Let's see how that works. So this is my level 1. Let's make sure it's saved. And then I want to create another level. Let's call it level 2. Save scene as level 2. Saves the exact same thing. Well, let's mix it up here a bit. I am going to put this sort of in the way there, just so you can see that it changed levels. Let's put this on top here. Okay, so we have 2 levels. We start off with level 1, and then we're going to change to level 2. Programmatically, here's how we would do that. I'm going to say you're going to throw 3 times. Every time you throw, I'm going to up the count. And then down here, underneath the return state, I'm going to say if count equals 3, if you've thrown it 3 times, application load level, level 2. Semicolon out of place. Aha, perfect, thank you. So count plus equals 1. When my count is 3, change my level to the next level. Okay, one other thing has to happen. You go to your build settings, and there are no scenes right now in your build settings. Add your current one in there. Go to level 2, build settings, add your current one in there. They're now able to be switched. You added them in, they got a number, they get the name in there. So you should be all set. Let's go back to level 1.